Hey guys, and welcome back. My name is Miss Danielson, and today I'm taking you through a lesson on cube roots. If you didn't join us for our previous lessons on cubes or on square numbers and square roots, I'm linking them down in the description box below because we will refer to them several times in this lesson, and you might want to start there and come back when you're ready for this. Let's get started. Much like square rooting, when we're cube rooting, we're asking where do these cube numbers come from? And like with square rooting, I suggested maybe they grew on a tree. So maybe cube numbers grow on a cube tree. And if that's the case, they must have come from their cube roots. Cube rooting is the act of finding which value was multiplied by itself 3 times to give a cube number. You should already be familiar with what cubing a value means. It means multiplying that value by itself 3 times. In our lesson on cube numbers, you worked out these cube numbers. I didn't ask you to memorize them, but I did ask you to go through and multiply them mentally so that you could recognize them if you saw them again. So let's try and put what we know about cube numbers into practice here. Which value was multiplied by itself 3 times to give this cube number? 3 times 3 times 3 makes 27. So if 27 is the same thing as 3 cubed, that must mean that the cube root of 27 is 3. Now be very careful because a very common mistake is that people think 27 is 3 cubed, therefore the cube root of 27 is 3 cubed. That's not the case. Cubing and cube rooting are opposite operations. So when I've gotten rid of this cube on the 3, it's gone over to the other side and it's become a cube root. The opposite operation of cube is cube root of 27. We don't have a cube on the right-hand side at the same time as we have the cube root on the left-hand side. It's moved. Next, is there a second possible cube root value? Because remember with square roots, we always said that there were 2 possible square root values, the positive and the negative. So does that mean that the cube root of 27 is either 3 or negative 3? Let's think about when we cubed negative numbers now. Remember our lesson on cubing negative values? We said that when you multiply a negative number by a negative number, like negative 2 times negative 2, we get a positive result. But then we take that positive result, so positive 4, and we multiply it by a negative number again, and we get a negative answer. So our conclusion was that a negative value cubed will stay negative. We can translate that backwards to say that a negative number cubed rooted would give a negative value, or a positive number cube rooted would always be a positive value. So no, there is no second possible cube root value. When you cube root a number, there is only one solution. If you cube root a positive number, that solution will be positive. Let's try another one. So 64. What's the cube root of 64? What value was multiplied by itself 3 times to give this number? If you don't have your cube numbers memorized, just think of the ones you know. For example, we just did 3 cubed, which was 27. Do you know any other cube numbers higher than 3 cubed? If not, just go trying. What about 4 cubed? 4 times 4, 16 times 4 is 64. So if 64 is the same thing as 4 cubed, then the cube root of 64 must be 4. Just 4, not positive and negative 4. That's only for square rooting. Can any number be cube rooted? We've done this with square numbers. Every positive number can be square rooted. What about cube rooting? Well, 60 is not a cube number. However, we know that to cube root it means to find what value multiplies by itself 3 times to give that answer. It's got to be somewhere between the cube root of 27 and 64. 27 is a cube number and 64 is a cube number. 27 is 3 cubed and 64 is 4 cubed. So the cube root of 60 must be between the numbers 3 and 4. But I'm saying closer to 4. Do you understand why I say closer to 4? Look at the number 60. Is it closer to 27 or is it closer to 64? It's only 4 less than 64, and it's 33 more than 27. It is much closer to 64. So a value between 3 and 4, don't say 3.5, it's definitely closer to 4. Make an estimate at what it might be. I'm thinking it'll be about 3.9, very close to 4. It's actually 3.914867641, and that number goes on because that's an irrational number. It could not be written as a fraction. The only way I could express it is by rounding and simplifying. So my estimate, 3.9, was a very good estimate because I wouldn't have written this whole number out anyways. Next, if you're going to use your calculator to check your answers, and I don't want you using your calculator otherwise, I want to make sure that you're not going to confuse the square root sign and the cube root sign. This is the type of calculator we generally have at our school, and this is the square root sign. It is not the same thing as the cube root sign, and don't make the mistake of thinking I just put 3 and then this symbol and then our number. This is your square root sign. You need to be familiar with your calculator, but on our calculators, we find the cube root function just above the square root button. So if you've got this printed on the calculator rather than on the button, what you're going to need to do is first push the shift button, that's this one here, let it go, you don't need to hold it down, and then push this square root button. That should allow you to cube root the value you enter after that. If you're not familiar with your calculator, I suggest you get familiar with your calculator and always try it out with numbers that you know the answer to. We know that the square root of 9 is 3. So try using your square root button, do square root of 9 and see if you get the answer 3. Your calculator will only give you one answer. It will tell you that the answer is 3, while we need to know that the answer is actually positive 3 or negative 3. You should also know that the cube root of 8 is 2. So use your calculator, and if you've got the same calculator as I've got, push Shift, the square root button, and 8, and work out your answer. It should be 2. If you don't have the right answer, you're not correctly using your calculator. Send me a message down below, and maybe you can send me a picture of your calculator and I can tell you where the buttons are. Let's explore cube rooting decimal values now. Now, if this seems too difficult and not within your reach, you'll need to check out our lessons below on squaring decimal values and square rooting decimal values, because I think we make it pretty straightforward. When we cube root a decimal value, we really have to worry about our place value. The cube root of 0.008 is actually the cube root of 8 in the thousandths position, so that's the cube root of 8 over 1,000. If we convert this to a fraction, it makes it a lot easier because then we can just think about cube rooting the whole number numerator and cube rooting the whole number denominator. The cube root of 8, you should know. Cube root of 1,000 as well. That's going to be 2 over 10, or 2/10. The name of the fraction is the same as the name of the decimal value. And since the question was given in decimal form, our answer should be given in decimal form. Now it's your time for practice. Without a calculator, work out or estimate the cube roots of these values. For questions 1 and 2, you should be able to cube root parts A and B, but part C is not a perfectly cubed number, so you're going to need to estimate that value. Use your answers to part A and B to help you with that estimate. For questions 1, 2, and 3 below, I'm just showing you the cube root sign so that you're familiar with 2 ways that you could be asked this question. Cube root this number, or work out, and then I have a cube root sign of the value. So try to remember what we did in our square rooting lesson and apply that here. Again, if you weren't here for that lesson, have a look in the description box below. If you feel ready, go ahead and hit pause, copy these questions, and work out your answers, and hit play when you're ready to take them up. I hope you've had a chance to hit pause, because here come your answers. If you struggled with questions 2 and 3 of the second section of this exercise, I'll give you a couple of hints before we take them up. But I'm hoping you had no problems with the first 2 questions. So question 1, is 5 closer to 1 or closer to 8? 5 is definitely closer to 8, which is why the cube root of 5 is closer to the cube root of 8. 1.7 is closer to 2 than it is to 1. For question 2, all of these values are negative values, and we know that if the value we are cube rooting is a negative value, then the cube root answer will also be negative. Note, negative 70 was not a perfectly cubed number, but it is in between negative 64 and negative 125, but quite a bit closer to negative 64. So our answer is closer to the cube root of negative 64. On to question 1 from the second section. That should have been fairly straightforward. You should have been able to cube root A and B and use those answers to work out an estimate for C. For question 2, this is where I promised you your hints. They are quite big numbers, but 27,000 is a perfectly cubed number. It is the product of 2 cubed numbers. 27,000 is the same thing as 27 times 1,000. And you can cube root 27 and you could cube root 1,000. I'll leave you some time to think about that. 8,000 is the same thing as 8 times 1,000. And you could cube root 8 and you could cube root 1,000. 10,000 is not a perfectly cubed number, but you could think of it as 10 times 1,000. You could estimate the cube root of 10, and you could cube root 1,000. The cube root of 27,000 would be the cube root of 27, which is 3, times the cube root of 1,000, which is 10. That's 30. The cube root of 8,000, cube root of 8 was 2, cube root of 1,000 was 10. And the cube root of 10,000, 10 is closer to 8 than it is to 27, so I estimated 2.2, and I times that by the cube root of 1,000, which was 10. 2.2 times 10, 22. Question 3, again, I'll give you a couple of hints for. These are decimal values. Part A is 125 over 1,000. So the cube root of 125 over 1,000. Question B is 216 over 1,000. So cube root of 216 over 1,000. Question C looks like 1500ths, and neither of those numbers could be cube rooted. But I could also write this as 150 over 1,000. So the cube root of 150 over 1,000. The cube root of 125 is 5, and the cube root of 1,000 is 10. So this is 5/10. The cube root of 216 is exactly 6. The cube root of 1,000 again is 10. So that'd be exactly 6/10. The last one is an estimate because 150 can't be cube rooted, but it is somewhere between 125 and 216. A bit closer to 125 than it is to 216 though. So it's closer to 5 than it is to 6. I put an estimate of 5.3 and I've divided that by 10. Admittedly, this lesson is getting quite a bit more challenging than the previous ones, so you really need to let me know in the comments section if any of this has gone over your head. I'd love to help you out, so please let me know. Otherwise, I hope that you found this helpful. Keep practicing, and I'll see you next time.